Okay, the absolute value function, given as two vertical lines, is something that has no effect if the number is positive, but if you apply it to something that's negative, it changes to positive. That's what an absolute value function is. Got it?
So,
Okay, so let's try this first example. Evaluate absolute value of x minus 4 for x equals to 1, 2, and say 7. Let's do it one by one. So, solution. If x is 1, how does this evaluate? 1 minus 4 absolute value, right? What is this same as?
1 plus 4.
So that's one of the common mistakes. Some people think that this absolute value means look at all the negative signs and change it to positive, but that's not what it is. What it does is you first have to compute whatever that's inside, and only after computing the value, you apply this thing, which is to change the negative to positive. So some of you are saying this should be 1 plus 4, which would be 5, but that's wrong. It's not 5. It should really be first computed. What's 1 minus 4?
Negative 3.
Negative 3. And then you take the absolute value. What's that? Positive 3. Okay. So using the same argument, what will be the value when x is 2?
2.
Yep. 2 minus 4, which is negative 2. That's 2. How about x equals to 7? What would that be? 7 minus 4 absolute value, which is 3 absolute value, which is 3. Got it? Okay. Okay, now let's talk about the graph of absolute value of x. Now to draw a graph of something, so we're really thinking of graph of y equals to absolute value of x. You first have to make a table of values, right? So let's put x here and then y here, negative 2, negative 1, 0, 1, 2, and then maybe 3 over here. Okay, what's the absolute value of negative 2?
2.
Positive 2. Negative 1? 1. 0? 0. 1? 1. Right? Absolute value of 1 is 1, right? Absolute value of 2 is 2, and then 3. Okay? And then you plot this. So negative 1, positive 1, negative 2, positive 2, positive 3, 1, 2, 3. So now you have the following points. Negative 2, comma, positive 2, so it's this point. Negative 1, comma, positive 1. 0, comma, 0. 1, comma, 1. 2, comma, 2, and then 3, comma, 3 here. And then if you did negative 3, it will also be positive 3, so this will be the graph. So it has this V-shaped graph. And what you need to do is you have to compare this graph with the following graphs. So compare y equals to x. Do you know the graph of y equals to x? Can you draw it on the air? It's a straight line 45 degrees, right? So it's this one. It has to pass through 1, 1, 2, 2, 3, 3, all of those. What about y equals to negative x? Well, if you plug in 1, it's going to be negative 1, so it's like 1, then it's negative 1. It passes through here. 0, 0, 2, negative 2, negative 1, 1. So you see that the graph is like that, right? Then you see something interesting going on, which is that this right side mimics this portion, and this left side mimics this portion. And you can write down that as the following. So you can say that absolute value of x is same as x if x is greater or equal to 0, and negative x if x is less than 0. Okay. In other words, on the right side, the graph follows y equals to x. On the left side, the graph follows negative x. And we can even check if this piecewise defined, this is an example of a piecewise function, right? The graph has different formulas for different cases. Okay? So we want to check if this piecewise function really is absolute value of x by checking those two cases. So, yes?
So for the greater than or equal to values, how come one has the equal to in the end compared to the other one?
Oh, thank you. The question was, why does this one have equal and not this one? Well, you could have put the 0 here. It doesn't matter because either one, when x is 0, it gives you the value of 0. Negative 0 is 0. So just usually the convention is just to put it here, but it's not wrong if you put the equal sign in here. Okay, thank you for the question. All right, so let's see what happens if we evaluate absolute value of 3 according to this function. Okay, so that's like plugging in x equals to 3. Now, if x is 3, is it greater than 0 or less than 0? Since 3 is greater than 0, it follows this one. What does it say? It should give back what you plugged in. So it does give you 3, right? What if you plug in negative 2? This time, negative 2 is plugged into x. Now, is negative 2 greater than 0 or less than 0? It's less than 0, therefore you have to plug it in here. What do you get if you plug in negative 2 into negative x? It will be positive 2 because, see, here's x and you're replacing x by negative 2. And negative of negative 2 gives you positive 2. Isn't that right? Yeah, so it's positive 2. So indeed, you can see that absolute value function is identical to this piecewise function, except that there's still something very strange going on here because originally I explained that, oh, absolute value is something that gets rid of minus, but right in the definition of that absolute value of x, there's a minus there. So what's going on?
Could be affected from an outside source.
I think I know what you mean, but it will be hard for other people to understand. Okay. So what is this minus doing here? What's the role of this minus?
To negate things.
Anyone? We just did an example where x is negative, right? What did this minus do?
Turn it back into positive.
It made it back to positive, right? So one thing that you have to be careful when you read this definition is that this negative x is positive if x is less than 0. In other words, don't be fooled by how it looks. This blatantly looks like a negative number, but no, it isn't. Why not? Because if x is negative, then negative of a negative number is positive. So it looks like a negative number, but it's really a positive number. It's a positive number taking some strange shape. You get that? Okay. Okay, so that was my short introduction to absolute value function. Now let me try to explain absolute value equations. before I move on to the absolute value equation, I need to make sense out of the following. So here's a question. If you have 2 and then 7, what is the distance between these two numbers? What is it? 5, right? 7. So how do you get 5 from 2 and 7? Subtract, right? So you do 7 minus 2 equals to 5. Now in general, here's what happens in general. The distance between A and B is A minus B, right? That's what we just observed, except there's a catch. We never let distance to be negative. Distance in physics is supposed to be always a positive value. So if this gives you a minus value, so for example, if we did 2 minus 7, it gives you negative 5, right? How do you convert it back to the positive value?
Absolute value.
Absolute value, that's what we were looking at, right? So if you take absolute value of A minus B, then that gives you the distance. And that can be used to find the solution of the following example. So solve absolute value of x minus 3 equals to 7. Let's say you have the following question, and I want you to know 2 ways of solving this. We will make use of the simpler second way, but knowing the first will give you a good idea of what's happening, right? So solution 1. In light of what we just found out, we're going to interpret this left side, okay? So this left side is the distance between what two numbers? No, x and 3. Right? You subtracted two numbers and took the absolute value. So the left side is the distance between x and 3 is what? Is equal to 7. So that's what this equation is saying. And that means you can draw the number line. And here is 3. Here's some x. And you want this distance to be 7. What am I? 10. Right? So we see that 10 is one possibility. But there's also another, yes?
-4.
Yes. There's another possibility. X could be over here. And this distance could be 7 as well. In that case, you do 3 minus 7, so it's going to be negative. So there are two possibilities. You have 10 and negative 4. Okay? Are we all good? All right, so let me give you the second solution. In the second solution, you think about this x minus 3 as something. So for a moment, you forget that it's x minus 3 that's inside the absolute value, just replaced by something. Okay? And if you do that, the equation given is something like this. Right? What can you put in here so that its absolute value is 7? 7, right? Absolute value of 7 is definitely 7, but there's another one. Negative 7. Right? So because of these two possibilities, we can say either x minus 3 is 7, in this first case, right? Or x minus 3 is, it could be negative 7, right? So in other words, there are two ways that this solution can happen. This can happen. It's one case where x minus 3 is 7, so that absolute value of 7 is 7, or x minus 3 is negative 7, so that its absolute value of negative 7 is positive 7. So there are these two cases, right? Solve this, what do you get? 10. Solve this, what do you get? You add negative 3 to both sides. Negative 3, if you move it to the right side, it's positive 3. What's negative 7 plus 3? Negative 4. So you get the same answer as the left side. Is that okay? Now let me give you this third solution, which is quite nice, but sometimes you can create some wrong answers. But let me show you this third method. You can take this and just get rid of the absolute value by saying that whenever absolute value is removed, it's just x minus 3 equals to positive 7 or negative 7. We saw something like this before. Whenever there's a square on the left side and when you take the square root, you need to introduce plus minus, right? So that's another way to do it. Whenever you have absolute value equals a number, just remove the absolute value and you get plus minus 7. Now you add 3 both sides, which means 3 plus 7 or 3 minus 7, right? What's 3 plus 7? That's 10. 3 minus 7, that's negative 4. And that will be the quickest. Right? That will be the quickest, except there's some cases you have to be careful about this. Do you have any questions so far? I'm giving you 3 ways. The first one is good for your intuition, especially you'll be made aware that such an equation should have 2 solutions. Okay? So it's important for that case. But in reality, when you solve, you should really go with solution 2 or solution 3 because you don't have to draw anything. It's quicker. Okay? All right. Let's think about the following example 2. Say x plus 2 is equal to negative 1. What's the solution? I'll give you some time to think. What's the solution of this equation? Okay, so let's think about whether negative 3 works. Oh, so that's not equal to negative 1, so that doesn't work. What's the solution to that equation? One plus 2 would be 3, which is not equal to negative 1, so that doesn't work. Yes?
This equation is just impossible.
This is impossible. In other words, no solution. Okay? So this equation will have no solution. Since absolute value of anything is always greater or equal to 0, the above equation cannot hold. So no solution. And this is the danger that I was trying to explain. If you simply say, oh, x plus 2, absolute value, okay, let's remove this away, and then put plus minus on the other side, and then you get x equals to negative 2 plus minus negative 1. You end up saying, oh, it should be negative 2 plus negative 1, which is negative 3, or negative 1. You get fooled into thinking that these are the solutions, but if you plug it back into the original, these don't work. Okay? So, in the last solution that I explained, what you need to be careful of is whenever you take away the absolute value, make sure that this right side is positive, or at least 0. If it's not positive or 0, if it's negative, then there is no solution. There's no need for proceeding with the solution because the solution wouldn't exist. Okay? All right, example 3. 2 absolute value of x minus 1 plus 5 is equal to 27. Okay, try to solve this. I'll give you some time to work on this. Okay, you would subtract 5 both sides. So 2 times absolute value of x minus 1 equals to 22. Divide by 2, giving you 22 over 2. See, in other words, you're doing something to x. You subtract 1, take the absolute value, multiply by 2, and then add 5. And I explained this shoes and socks thing, right? When you go out, you put your socks first and then shoes. When you come in, you take off your shoes and then socks. It's the reverse order, right? So if you do something to x, and you want to get rid of things done to x, you have to do the reverse order. The last thing done to the left side is 5, so you get rid of that, and now you get rid of 2, and now you, this is, by the way, 11. Now, how do you remove absolute value?
Plus 1.
Yeah, remove the, sorry, this is 11. If you remove the absolute value, that gives you plus minus 11, right? And now you add 1, and you've removed everything from x, which will give you the solution. What is this equal to? This is 1 plus 11 and 1 minus 11, which is 10, 12, and then negative 10. So that's the solution. Okay? Any questions? Let's just do one more equation and we'll move on to inequality. Okay. Okay, so let's try this. You subtract 8 both sides, right? And you get 3x minus 1 equals to 4. Right? And then if you think about this as something, and you're taking absolute value to get 4, what could this be? It could either be 4 or negative 4. So we know that this thing inside, for this equation to work, this thing inside must be 3x minus 1 equals to 4, or 3x minus 1 equals to negative 4, right? Okay. Add 1 both sides, you have 3x equals to 5. Divided by 3, you get 5 over 3 for one answer. And if you add 1 to this side, what's 1 minus 4? Negative 3. And you divide both sides by 3, you get x equals to negative 1. So the two answers that you get are 5 over 3 and negative 1. Okay. Did anyone do it differently and then got a different answer?
I tried to reverse engineer it.
Huh?
I tried to reverse engineer it, but then they only gave me one solution. What did they do?
Oh, because you forgot that this also could be negative 4.
Yeah,
Right,
exactly.
yeah. Good. So you reverse engineered and asked, what could this be? Well, it could be 4, and you only got this answer.
Yeah, and then
Yeah.
and I did it.
Yeah. Did anyone do something else? See, the reason I'm asking you this, when I give this question to during the exam, like I would see at least like 1/3 of the class doing this. They would write 3x minus 1 absolute value and then say, oh, 3x plus 1 is 4. So 3x is 3. X is 1. What's wrong about this? What did this person do?
Just
this person just took absolute value of each one of them, right? And said, oh, I don't see a negative sign here, so it must be 3x. Minus 1 should be plus 1, and then did this. Is this right?
No.
No, that's misunderstanding what absolute value is doing, right? Absolute value is saying you first have to compute whatever this is, and only after that, when you're sure it's minus or plus, then you make it plus. That's what this is saying. Don't misunderstand what this absolute value is doing. Right? So if you checked both cases, so for example, if x is negative 1, indeed, when you plug it in here, it's 3 times negative 1 minus 1. What's this? Negative 4, right? What's this? Positive 4. Right? So it does work out. Right? What if x is 5 over 3? Well, 3 times 5 over 3 minus 1, absolute value. 3 cancels, right? What's 5 minus 1?
4.
That's 4. Absolute value, what's that?
4.
4. So, both of these are solutions, you can clearly see. Right? Yeah. But tragically, so many of you will do what I just said. Yeah. Don't do it, please, I beg you. Right? Okay. Now let's... Okay, just like how we solve the absolute value equation, let me first show you how to solve this graphically. So, what's the meaning of absolute value of x minus 3 in terms of distance? It's the distance of what? Distance of x and 3. Right? It's the distance between x and 3. Right? Is less or equals to 4. That's what it's saying. Right? This is less or equals to 4. So, if here's 3, what has distance less than 4? Well, 4 is okay, right? So this distance less than 4, right? So this x could be 3 itself, that's fine. You can be 4 or even 3.5. That's fine. So anything in here is good. But as you go further to the right, the distance will increase, right? And now, the next question is, what's the maximum you can go and still manage to say it's less or equals to 4? Huh? What's the maximum distance you can go to the right?
7.
7. Oh. You can go all the way to 7. And 7 minus 3 is 4. Absolute value of 4 is less or equals to 4. Isn't that right?
Yeah.
Yeah. So 7 is the maximum you can go to the right. On the other hand, how far can you go left? Negative 4. Right? No, negative 1. Negative 1. Right? Because, see, this is distance 4. Right? So x could be anything between negative 1 to 7, and this will be satisfied. Do you agree? And therefore, the answer would be x is between 7 and negative 1. In terms of interval notation, you write down negative 1 and then 7. These are solutions. Okay? In terms of the picture, it's this, including the endpoints. Anything in between negative 1 and 7 is a solution. Okay, solution 2. It's a similar idea as before when we solve equations. We take this equation, take this inequality, and for a moment forget that this is x minus 3, just treat it as something. Something that's less or equals to 4. And think about various values that you can have in here. Okay? So, give me a number that will satisfy this inequality. Anything.
2.
2. 2 will be absolute value of 2 is less than 4, right? 4 is still good. Give me some negative number that will satisfy this. Negative 1, negative 4. How about negative 5?
No.
No good. Yeah. So this question mark should be between what and what? Negative 4 to positive 4, right? So we know that this question mark, this thing inside, must be between -4 to 4. But what is this thing? It's x minus 3, isn't it? So you replace this question mark by x minus 3. And now there's a simple way to solve this. You simply add 3 all across. See, if you add 3 everywhere, the inequalities are still preserved. But what is -4 plus 3? -1. X minus 3 plus 3 will cancel the 3's, and it's just x. What's 4 plus 3? 7. Done. That's the solution. All right? Simple enough?
Yes.
Okay, great. So now, let's do a similar question. This second approach will be what we're going to do, because like drawing the picture every time, although it helps you with the intuition, it kind of gives you some feeling of what's going on. It's tougher to think. So let's think about the second case. What if you have x minus x, let's say x plus 2 is greater than 3, for example. Let's think about that. Okay. Solution. We'll take a similar approach like that. First, don't think about x plus 2. Just simplify that and ask yourself this question. What are some numbers satisfying this inequality? 3, -3, another one. 1's no good because 1 is, absolute value of 1 is 1, it's not greater than 3, so 1's no good. 4 is good. Give me another negative number. -2 is no good, absolute value of -2 is +2, it's not greater than 3. -4, -5, those are good, okay? So, what do you think? If this is positive number, then it has to be greater than what? 3. It has to be 3 or greater, right? Or, if this is a negative number, it has to be less or equal to what?
-3.
-3. Okay? Yeah. See, just thinking of this as something simplifies the situation. It's easier to see what's going on. And then, now you replace this something by x plus 2. That's what it was, right? So you can say x plus 2 should be greater or equals to 3. Or x plus 2 is less or equals to -3. Let's solve this separately. If you subtract 2, what do you get? X greater or equal to? 1. Or if you subtract by 2, you get x less or equal to? What's -3 minus 2? -5, yes. Okay, so that's the solution. Now let's try to graph it. You don't have to put all the numbers, you just have to put -5 and 1 because those are the only ones discussed here. But make sure that you put -5 on the left, okay? Always on the number line, the smaller number should happen on the should take place on the left. Okay, and then this one is saying here's -5, it's including, the equal sign is there, so it includes -5. It goes this way, right? And then, what about this one? It's 1 and afterwards is this one. So, it's either this one or that one. Anything that's 1 or greater, anything that's -5 or less, if you plug it in, you'll see that the inequality is true. Now, how do you write this in terms of interval notation? Well, what is this interval? Starts from where? It stops at? So -∞ up till -5. Now, what kind of bracket? Open. Always open for infinity or -∞. How about this one? Closed. Okay. How about this one? From 1 till infinity. What type of bracket? Closed. And then here, open. And then, if you have more than one interval as your solution, you always put something called the union. Okay. So that's how you write down your answer in interval notation. Okay? All right. sorry, that should have been example 2. Okay, now try this example 3. 3x minus 1 absolute value is less than 2. I think some people are thrown off by being a strict inequality. Some people are thrown off by there being some number in front. Well, first of all, you can just treat this entire thing as a question mark. So there's no difference. But then this is sometimes causing a problem. Like, what satisfies this? This time 2 doesn't satisfy this. But 1.99 still satisfies it, right? So it's a bit trickier to handle when it's a strict inequality, but if it helps, just put an equal sign for now, solve it, and then remove the equal sign. It'll be the same. Okay? Yeah. If there's a conceptual problem dealing with strict inequalities, you can always put an equal sign there, and then remove what it is. All right. So if you had this, what would your conclusion be? Question mark should be between what and what? If something's absolute value is 2 or less, what could the thing inside be? Between? -2 to +2, right? That's what you would get. But then, if you're working with strict inequality, just delete this equal sign, and this is fine. Okay? That's what you have. Is that okay? All right. Now what is this question mark? It's a 3x minus 1, right? So you put 3x minus 1 between -2 and 2. Now you just have to solve this. How would you solve it? Give me recommendations.
Add 1 to all 3.
Add 1 to all 3. So you get -1 less than 3x less than 2 plus 1, which is 3. Now what do? Divide by 3 for every one of them. So that you get -1/3. 3 over 3 is 1, so you get x. 3 over 3 is 1. Right? That's all for today.